This video is about Selenium rectifiers, as you might have guessed by the fact that there's a bunch of Selenium rectifiers lying around on the desk here. Also, excuse the not so great lighting. I can see the shadows too, but it's currently night here, and I've got to shoot those videos when I have time, and I happen to have time now, so we're going to do this. Selenium rectifiers were around from, I think, the early 60s to, well, mid-70s, when they were surpassed by silicon rectifiers. It's just a rough estimate by me. You'll find those a lot in old radios. You'll also find them in old TVs. Often they're also bypassed with a silicon diode. A lot of people like to just replace them whenever they come across them. In Europe, the types you're most likely to find in radios are these flat pack ones and these sort of round ones. These styles here you'll find in a lot of old battery chargers and power supplies and stuff like that, where you need the amperage. And then lastly, these ones here, and here, you're more likely to find in high voltage supply sections of television. Sometimes I think this is likely to have come out of a television. But yeah, also all applications. This is certainly not out of a television. So, how do those Selenium rectifiers work? Some of these are actually, that I have here, are actually bridge rectifiers like this and this and this, and some are just diodes. But if you come across a Selenium bridge rectifier that looks like this, it's actually kind of obvious how it works. These plates here are coated in selenium, and they're then plated with some lacquer or something. And each of these plates is basically one diode. And so you can count them 1, 2, 3, 4, 5, 6, 7, 8. And that means the 4 diodes that this bridge rectifier has, they're 2 plates in series each. So each of those is basically one diode in a bridge rectifier. And each Selenium diode has a reverse breakdown of around 20 volts. So the rectifier like this, if you see it, it's probably good for up to 40 volts. Sometimes a bit less, sometimes a bit more. This has 4 plates, so it's a 20 volt rectifier, something like this. And also for each square inch of a rectifier like this, in area you can, so it's 1 or 2 amps. Just a rough estimate. On this one it actually says, I think, what it's good for, but it's in Russian so I can read it. Yeah, on rectifiers like this, it will have it in print. This is 30 volts, 1000 milliamps. This is what this is good for. And I think those are selenium, because I opened one of these before and there were little selenium plates inside. Although I don't know if they also made silicon rectifiers in that sort of case. That is entirely possible. This one is a bit smaller. This one, you can see 30 volts and 200 milliamps. While this one is, this is supposed to replace a rectifier tube, 300 volts, 75 milliamps, which is basically a lot like something like EYY 13, I think was one, or EZ80, 81, 83. the common rectifier tubes. I don't know the number on the top of my head, but yeah, these you see a lot in radios that basically have tubes in them, and they're just a replacement for the rectifier tube. Same with these, you find them a lot in radios, but then with a higher voltage rating. So yeah, that's basically that. You should also see on all of those, there's always this wire here. On the ones that have the stacked plates, like this one has it too. And this is usually, these two are where the AC goes in. This is plus and this is ground or minus. Same with this. It even has the colored markings. This is red, this is positive, this is black, so negative, and the two yellow ones are the AC. Yeah, this one is basically just one large diode. It goes in from here and goes to here. Does it say something on it? Nothing that I can really read, but this is probably a couple hundred volts of rectifying power. If you have these, you actually see there are versions that have red and a blue lead. There's positive and negative, and two yellow ones for AC. But they also make those in versions that basically replace a single diode, where you just have a positive and negative lead. And then there's also the style like these here. It's basically just stacked selenium plates, one on top of another. And these replace double diode tubes, where you would have two AC, basically a split winding transformer, where you have two windings on the AC, and you would connect those up to two diodes and get your plus and get your plus from the rectifier and get the minus from the center tab of the transformer. That's how you usually do it. And this, I think, is like this, although I'm not sure because it says plus on here, and this is like a little AC wave sort of thing. So maybe this is just a regular rectifier, but it uses the center as another tab for the AC or something. Or maybe this, I don't know. But they have those. Just don't know if this is one of them. And then there's also these, which is, they have loads and loads and loads of little stacked selenium plates in here. And I reckon this is some sort of high voltage rectifier. Just a single diode going from here to here. And yeah, this is basically all that I have to say about the different types of selenium rectifiers. Often when you repair a radio, and this is blown, and you will definitely smell that it's blown because it gives up a very, very nasty smell. And it's kind of hard to describe, but it's not pleasant. Often in old gear, they just bypass it with a silicon diode, which is not what I'd recommend. I'd recommend just what I usually do, and what I recommend is tagging in, if you have something like this, tagging in a silicon rectifier, like a bridge rectifier, and then also put a resistor into the plus line. So the plus, the red line that comes off here. You should put a resistor in there because these selenium rectifiers have a much higher internal resistance than a silicon diode would have. They have a larger forward voltage drop of about 1 volt per plate. So this is 2-3 volts drop per plate, but also resistance that if you load something like this down, you'll really see the resistance. So, yeah, it depends a bit on what sort of circuit you have, what sort of resistor to tag in there. But a couple hundred volts is usually a good thing to do. A lot of radios will definitely work if you don't do that, but it just it loads the tubes down a bit higher. It is probably bad for the capacitors, especially if they're old anyway. And just having a higher voltage there isn't always something that I personally recommend. So yeah, that's what I've got to say about Selenium rectifiers.